This is just a quick little video explaining crashing. The best example of that is from our exam question booklet, looking at question number 42. The whole idea about crashing is trying to reduce the critical path and therefore the amount of time that it takes to complete a job. If you look at this particular diagram, you can see the first thing that I did was forward scanning and backward scanning and then identify the critical path. The float times have all been calculated there in blue, as you can see as well. Now the question is asking us, the project is to be crashed by reducing the completion time of one activity only, so only one of these activities is reduced. This will reduce the completion time of the project by a maximum of however many hours. When you do this question, my bit of advice for you is to take a look for the vertices. So these key points, 1 and 2, stand out because you can see I've got the critical path here, but I've also got an alternate route. And then if I go from 1 to 2, I've got this critical path, but I also have 2 alternate routes. Obviously, this is just going to take me to the finish. So when we have a bit of an analysis of position 1, so I'm just looking at it here, what I can see is that BD currently has 5 hours, but if we look at activity A, it goes for 1 hour. We can see there that I can reduce BD by a maximum of 4 hours before A will become the equal critical path. So I can reduce that by 4 hours and therefore reduce the job overall. When I take a look at the next section, so going from 1 to 2, I can see I've got along there as my critical path, so C, E, H. I can only reduce that, each one of those, by 1 before F becomes the critical path. So here you can see F, it's got a float time of 1. So I can reduce either of these by 1, and then that will make an equal critical path here for F. So the overall maximum amount of time that I should reduce one activity, if I reduce activity B to be 1 hour long, there's a reduction of 4 hours. My finishing time will be reduced by 4.